Welcome back guys to our 5th class, which is network addresses. Under network addresses, we will cover what we mean by IP address, the IPv4 classes, understanding what a subnet mask means, network ID mean, and host ID mean. Okay, then we'll understand the differences between IPv4 and IPv6 addresses, after which we will look at MAC addresses, then finish with the differences between IP and MAC addresses. So without any further ado, let's move to our next topic. Internet protocol address, which some of you call IP address. IP address is a logical address that works at the network layer of OSI model to enable devices to communicate. IP address is a logical address, just like your cell phone numbers. IP address is a logical address that works at network layer of OSI model and it enables devices to communicate. Okay, understand what IP address means, the layer it works, and the function of IP address. Okay, so there are two categories of IP address. There is IP address version 4 and IP address version 6. So we will start by looking at IP address version 4. IP address version 4 consists of numbers divided into 4 sections called octets, and these octets are separated by dots. And this one is an example of an IP address. This one is a Class C address. Class C IP address. We will look at it, don't worry about classes. That's our next topic. So this is an example of IPv4 address. It consists of numbers, these are numbers, divided into 4 sections or octets. These are octets, separated by dots, as you can see, dots. Each octet contains 8 bits. This octet contains 8 bit, this octet contains 8 bit, this one and this one. Okay, and the size of IP address is 32 bits. 4 octets, 8 bits, 32 bits, that's the size. Under IP version 4 address, we have a private and a public address. We have private IP address and a public IP address. The difference are, under private IP address you cannot access the internet, but under the public IP address you can access the internet. For example, in the below diagram, this is a private IP address. The private IP address is that IP address that is assigned or configured to a computer either manually or dynamically. So under this case, these are our private IP addresses. These computers can communicate using these IP addresses. And now, for these computers to connect to the internet, they must be assigned a public IP address. This one is done by ISP, Internet Service Providers, but this one you can done on your own. Okay, or the router in that network that is configured to assign any host device IP addresses dynamically. Okay, when a router is configured to assign IP addresses to host devices dynamically, these devices will obtain IP address from that router. Okay, so you have to understand the differences between public and private IP addresses. A private IP addresses can enable you to communicate within a LAN. Okay, but using a public IP address, you can communicate through in the internet. Okay, you can get online, you can chat, video conferencing, and so on and so forth. A private IP address, it is free. I just go to my computer and configure these IP addresses. It doesn't cost anything. But for you to involve the ISP to assign you this public IP address, you must pay. Okay. By default, it is in the computer. Private IP address. Okay. The public IP address is from ISP, Internet Service Providers. So, if you want to test or check your private IP address, you open command prompt. Let me just go to command prompt. Command prompt. And then you type IP config all like this / all, and you hit enter. So I'm already connected to a Wi-Fi. So my IPv4 address is this one, and the command that I used to check was IP config all. So I've already known my IPv4 address, which is this one. Okay, so for you to check your public IP address, you go to your browser and you type what is my IP, just like that, and you hit enter. So my public IP address is this one. This one is the IP address assigned by the Internet Service Providers. Example, by private IP address is like this one. Okay, but a public one is this one. Okay, so I hope you understand the difference. A public one helps you to connect into the internet, but a private one communicate within a LAN environment. Okay, so let's see what we have next. IPv4 classes. We have 4 classes of IPv4. The first class is class A, second one class B, third C, fourth C, D, and fifth E. In class A IPv4 address, the range starts from 1.0.0.0 to 126.255.255.255. Okay, the range starts from 1 to 126. Understand this one. 27 is called a loopback IP address. A loopback IP address is the kind of IP address that is used to test self-communication. Self-communication. Suppose it's used to test whether the network interface cards are functioning. Self-communication. Okay, I hope you understand the loopback IP address under class A. So we can say just class A is 1 to 127, but from 127, within the 127 range, it's not used to assign any host computers because it is used as a loopback IP address for self-communication. So under class A IP address, we have the number of network 8 bits, and the host party are 24 bits. That's giving us a subnet mask of 255.255.0.0.0. So these 3 parts are the host parts, but the first part is the network part. This one is a subnet mask. So you have to understand the class A address, the host part, contains 8 bits. In class A, the network part contains 8 bits, while the host part contains 24 bits. 888, 24 bits. Total number of networks in class A address is 128. How to achieve this? You have to use a formula of 2n minus 1, which is 2 network bits are 8 minus 1, which is 7. Okay, bringing to 128. This formula of getting total networks: 2 raised to n minus 1, where n is the network bits, the bits under network portion. Okay, remember the network portion of class A IP address contains 8 bits. Okay, so available host, we use the same formulas: 2n now minus 2. Okay, where n represent the host bits. The host bits here are 1, 2, 3 octets times 8 bits, 24, which is 2 raised to 24 minus 2, bringing this one. Okay, I hope you understand how to get the total number of networks under class A address and under and available hosts. Okay, so let's proceed to class B. In class B, the range starts from 128 to 191. So any IP address within this range, within the 128 to 192, within this range, is classified as class B IP address. Okay, under class B IP address, we have 2 network portion. We have 2 octets representing a network portion and 2 octets representing host portion. So under here, the subnet mask is 255.255.0.0. Okay, so the 2 network portion, the two octets, so the 2 octets represent host portion and the 2 octets represent network portion. And we use the formula here to get the total number of networks, the same as here: 2n minus 2, which is 2 number of host bits are 1 to 16 minus 2, and you get here the same formula as we applied at class A IP address. So class C IP addresses. A class C IP addresses fall within a range of 192 to 223. Any IP address within this range is classified as a class C IP address. A class C IP address has the first 3 octets representing a network portion and the last octet representing a host portion. So subnet mask here will be 255.255.255.0. So these octets represent host bits, while the 3 octets represents network bits. So the same way, we use the same formula here as we used here, n minus 5, where n here represent the network bits. The network bits are 1, 2, 3 times 8, 3 octets times 8, 24. Okay, so you have to understand that one. And then here we use the same formula of 2n minus 2, where n represents the network bits. The network bits are only 8, only one octet, 8 bits, minus 2, which will be 256 minus 2 is 254. Okay, so I will understand how you can differentiate between a class A, class B, and class C IP addresses, noting the network portion and host portion, the total number of networks and available hosts, and then subnet masks in every case. Okay, so class D IP addresses are not signed to any host in the network. They are used for the purpose of multicasting. Multicasting, we'll discuss it in our next class. Multicasting is a situation where a data is sent to a group of devices. You multicast. You have to send one data to a group of devices. Okay, multicasting, and it falls in a range of 224 to 239. That is class D IP addresses. Then coming to class E IP addresses, they are also not used to assign any host devices in a network. They are mainly used for R and D, which is research and development. Okay, and they fall within a range of 240 to 255. Okay, so I hope you understand these 5 classes of. Let's see what we have next. The differences between IPv4 and IPv6 addresses. So IPv4 was deployed around 1981, but IPv6 1998. As discussed earlier, IPv4 is a 32-bit IP address, but IPv6 is 128-bit IP address. So under IPv4 we can have up to 4.3 billion addresses, but under IPv6 we can have this number of IP addresses. It's too large. Around under zillion. It's too large. 10 raised to 28 times 7.9. So large. Under zillion addresses. So under IPv4 addresses must be reused and masked. Okay, you know, these addresses cannot satisfy all the devices under the earth. Probably there are too many devices than this number in the world, so we have to reuse the addresses. But you know, under zillion addresses, it's too large. Every devices can have a unique address. So you have to understand the differences between IPv4 and IPv6 addresses. Okay, see what we have next. Media access control addresses, known as MAC addresses. MAC address is a physical or a hardware address. These hardware addresses are burned in our CPU. You know, when you have a network card, whether it's embedded in the CPU or it's removable. The MAC address is burnt inside there. It's very difficult to alter it. You cannot alter any MAC address that is burnt to a device. So it enables the communication in the network at layer 2 of the SI model, data link layer of SI model. So every device has a unique MAC address. Every device in the network has in the world has a unique address. Unlike IP address, where several devices can have the same IP addresses, okay, even in a different network. Okay, yeah. So in the case of MAC address, every device has its own unique MAC address. Okay, so it's permanent and cannot be changed. It's burnt in the network interface cards. It's made up of 6 octets separated by colon, a dash, or dots, like this one. This one, the first octet, second, third, fourth, fifth, sixth. 6 octets separated by dots. Okay, each octet containing 8 bits. Each octet containing 8 bits, meaning it's a 48 bit in size. Unlike IP, which is 32 bit, IPv4, which is 32 bit in size. Alright, MAC address is normally divided into 2 parts: a vendor part and the host part. So this one can be different in devices, okay, but this one must be the same because it represents the vendor allocation scheme, okay, but this one is for host. So set by the vendor allocation scheme and the host can be different, but the vendor must be the same. Okay, all right. A MAC address is a 6-byte hexadecimal address, 6-byte octets, but IPv4 is a 4-byte and 6-byte for IPv6 addresses. Okay, in IP address we have 4-byte for IPv4 and 6-byte for IPv6 address. We use a protocol called Address Resolution Protocol to get MAC addresses of devices. Address Resolution Protocol to get MAC addresses of the devices. But in IP address we use Reverse Address Resolution Protocol to get IP address of devices. Okay, network interface card manufacturers provide the MAC addresses, but network administrator or ISP provides IP addresses. See the difference? Okay, MAC address is a physical address of a computer, but IP address is the logical address of the computer. Address, it operates at the data link layer of a SI model, but IP address a network layer of a SI model. MAC address helps to simply identify the device or uniquely identify the device. IP addresses identify the connection of the device in the network. Okay, MAC address of a computer cannot be changed. We've been saying this several times, but you can modify IP address. And that marks the end of today's classes. See you again in the next class. Bye.